We are going to get started. This session will be recorded. Hello and welcome to Sterling and VMware's Power Block session. I am Shannon Williams, a Sterling Partner Business Manager. We know your time is valuable, so we want to thank you for choosing to spend a portion of your day with Sterling and VMware. Before we dive into the demo, I wanted to give you a brief overview of Sterling's capabilities. Sterling is a principal VMware partner and a preferred services partner authorized to sell and service VMware solutions to customers across the nation. With 50 plus technical staff and 75 plus sales staff, all trained on VMware offerings, we are sure to provide you with industry best value on all of your client to cloud IT needs. As you can see from this slide, Sterling holds many VMware competencies, including 2 master services competencies and more coming soon. Next slide, please. Sterling offers complete customized solutions from client to cloud. We serve on multiple federal and state and local government contracts and support all industry verticals. Security is extremely important here at Sterling. We have a robust security supply chain, including OTIPs and CMMC certifications. For any questions about Sterling, please use the email aliases that you will find at the end of the demo. For questions during the demo, please put them into the Q&A feature at the bottom of your screen, and we will address them at the end. Now I will turn it over to Cloud Architect Billy Downing to explore Tanzu with PowerStore, reference architecture.
Yeah, awesome. Hopefully, I'm assuming everybody can see my screen and hear me okay. So yeah, my name is Billy Downing, and today we'll be talking about how we can use vSphere with Tanzu and integrate that into our existing PowerStore environment, or if you're exploring, storage solutions that you want to ensure can handle future workloads as you progress into a more modern infrastructure towards containerization, Kubernetes, and all the good stuff that comes with vSphere with Tanzu. So what we're going to talk about first is I'm just going to frame what vSphere with Tanzu is in kind of the context of the demonstration that I'll be giving later on. What that looks like, what is the architecture of vSphere with Tanzu, and how does that actually incorporate a Kubernetes platform on top of vSphere. Then we'll talk about specifically how does Tanzu then integrate directly with PowerStore and what sort of unique integrations exist there to allow you to better manage your storage and incorporate that into your containerized workloads, as well as your existing virtual machine workloads, and how you can kind of use vSphere with PowerStore as a platform for your existing workloads as well as your future workloads. Then we'll jump into an actual demonstration environment that I have. So it's a live environment that we use. So it's going to be, all bare metal stuff. And the goal there is just to help you visualize what the solution actually looks like if you were to adopt this, and what sort of different tools you'd have at your disposal to incorporate storage and persistent data with your Kubernetes environments. So first, we'll start off with what makes up vSphere with Tanzu. So we'll start at the foundation. You have your ESXi hosts. This is what you've been running for, the entire time now. You have vCenter on top of that to orchestrate and aggregate all of your ESXi hosts. So now you have compute resources managed to develop virtual machines on top of your infrastructure. The next thing you do is connect your storage, your network. This can be, software-defined storage like vSAN. This can be external storage over a fiber channel, over iSCSI, whatever mechanism you use to, store persistent data across your environment. And then obviously we have our network component as well. And again, that can be if you're doing the VMware Cloud Foundation stack or the full software-defined data center, that would be NSXT or some other flavor of software-defined networking. But that doesn't have to be the case. And, in the environment that I'm using today, I am using NSXT, but that's more of a tool that we just decided to use, but it's not required for any of the deployment that we're doing, what we're demonstrating at all today. So what we have here is a typical environment. This is a very common, ESXi environment with vCenter aggregating, and we have storage network. We can run virtual machines as we see fit. So at this point, we might be getting questions from our application owners, or perhaps we have in-house development, and everybody's talking about how do we develop applications in a cloud-native way? Or rather, how do we develop applications using containers to provide the benefit of resiliency, scalability, and mobility specifically? And how can we enable our existing platform to facilitate that type of development paradigm? So this is where we enable this cluster with vSphere with Tanzu. So the first step Just like vCenter is the control plane for our ESXi hosts, Kubernetes also will have its own control plane. And so when we enable this, we're going to go ahead and deploy a supervisor cluster, which is going to deploy a few Kubernetes control nodes. So we'll see a cluster of 3 virtual machines deployed. That will make up our control plane. And the way that this control plane is going to interact with our existing ESXi host is going to be used through a kubelet, which is installed on the ESXi host itself. And that provides the capability for Kubernetes to control our ESXi hosts and schedule vSphere pods or subsequent guest clusters on top of our compute environment to then enable us to have the platform for Kubernetes control as well as our standard and typical vCenter control of our virtual machine resources. So as a result of that, we have this new construct that we're able to deploy on top of our infrastructure. So everything we see here is within a namespace. A namespace is an architecture paradigm within Kubernetes for isolation. So within a namespace, we can allocate kind of plots of land or spaces for our application owners or our developers to work that they can completely have control of within the guardrails that the administrator set. So the intention here is that we're trying to provide our developers, our application owners with a platform that is self-service in a way using tools that they are used to using, such as Kubernetes in this case. So if we have developers that are attempting to deploy an application through a CI/CD pipeline and they needed a Kubernetes API endpoint to actually deploy the workloads, then they can go ahead and enable your existing platform today, add the capability rather than building an entirely new infrastructure, and then hand them over the keys to their specific namespace where they can build the objects that are required for their application. They can build virtual machines that will be managed by Kubernetes. They can build subsequent Kubernetes guest clusters. So this would be somewhat of Kubernetes managing Kubernetes. And there's a few reasons that you can do that. I can talk about that once we get into the UI and discuss, how this actually looks from a vSphere perspective. And then finally, we can deploy vSphere pods, which would be the equivalent of, or similar equivalent of a native pod running on bare metal. It's a little bit different, a little nuanced from that, but the semblance is still, it's very similar to what you would expect out of a bare metal pod as far as resiliency and speed of deployment. And all of this happens within the guardrails that we as the vSphere administrators set up for our developers to access. We can set guardrails for, how much storage they can access. We determine what storage they can access. And we're going to get into details of how that actually is provisioned and how we're doing that. But we can also provision, how much compute can they use? How much memory can they use? How many namespaces that can they actually contain? And there's all sorts of limits and quotas that we can determine. So at the end of the day, our intention here is to provide a platform for our consumers. Consumers can be, our developers or application owners, whoever that may be. But our goal here is to have a single platform that we can run our existing applications and, virtual machines we see up here on the left, as well as a Kubernetes platform to start that process of building out applications in containerized formats, all using the same UI with the same skill set that we have today. So what that provides at the end of the day is going to be one side, we have our vSphere administrators interacting with the same vCenter API, whether that be through vSphere or through PowerCLI or whatever tools you're using today. But it also provides a secondary API for your application owners to utilize that they're more familiar with. So the goal of this is to provide new capabilities on your existing platform without having to reskill all of your engineers or deploy an entirely new infrastructure just for the sake of the benefits of Kubernetes. So how does this translate into, how are we integrating this into PowerStore, and what are the unique facets that we get out of a vSphere with Tanzu environment integrated with our storage deployment? So first off, let's talk about, the typical idea of Kubernetes is running stateless applications. Pods are ephemeral. So the idea of a pod or a container in this instance is going to be that the container only has ephemeral data as long as the pod is alive. And if you're familiar with Kubernetes or containers and how those architectures typically work, that's never a guarantee. So the idea is that everything is stateless from the initial onset of Kubernetes. But as we've progressed into a more production environment or production ready environment that enterprises are requesting, we found that pods can also be useful in a environment that requires state to be maintained. And when state needs to be maintained, we have to have somewhere to put that state. We have to have somewhere to put the VMDKs that are attached to the pods that then can, remain with that data stored there. Perhaps you're running a database in Kubernetes. Perhaps you're running an application that has sort of caching mechanism that you want to live throughout the pod lifecycle. And really what this allows us to do is just like we do with our virtual machines, where we separate the VMDK lifecycle can be separate from the virtual machine lifecycle. We can now treat pods as first-class citizens in the same way. So how do we do that? There's a few different components that go into that. And these are all going to be, some of these are specific to Dell PowerStore, and some of them are generic of how vSphere interacts with storage. But these are the tools that I'm going to demonstrate later on when we actually get into the environment. The first one is going to be the virtual storage integrator, the VSI. This is going to be a plugin directly in vSphere that is Dell's PowerStore specific. And this is how we're actually going to interact with our Dell PowerStore to provision data or provision volumes for ourselves. We're going to use this to determine storage classes, and everything else that we can interact with our storage device directly from vCenter. And the way that's going to actually do that is through vVols and APIs for storage awareness. So these three components here are going to make up a large component of how we're interacting and integrating into our PowerStore environment. And this is going to allow two-way communication between our PowerStore appliance and our vSphere environment so that both of them act as a single unit or a single platform to provide compute from vSphere and storage from our PowerStore environment, all in a dynamic fashion as we need it, so that our developers, as they're deploying Kubernetes clusters, as they're deploying pods, as they're deploying, whatever they need within their namespaces, they have access to dynamic storage that they can allocate themselves within the guardrails that our vSphere administrators set. So how do the pods actually integrate and actually create relevant volumes that they can attach to? So in a VMware environment, that's going to be kind of the gateway to that is going to be the Cloud Native Storage interface, or the CNS. This is a service that is going to interconnect that Kubernetes API into the vCenter API to interact with storage. And if you're familiar with Kubernetes, you would be aware of the container storage interface. So what this is, the container storage interface, and the reason I've made this blue, if we look at the last couple objects I've talked about, they're all in red, and this one is in blue. The red objects are facilitated by vCenter. So these are all built into vCenter itself. These are for the normal integration with any storage provider, whether that's virtual machines, whether that's pods or whatever it is. The container storage interface is going to be that gateway into the Kubernetes environment. So the CSI is going to act like that translator that can translate vCenter objects into Kubernetes objects. So on the left, we have, for VMware, we're going to be deploying VMDKs. We're going to be deploying those on dynamic virtual volumes, and we're going to integrate that with PowerStore. But then how does that get translated to a Kubernetes type of environment? That's going to happen through the container storage interface. So the CSI components are going to be running on our actual Kubernetes clusters, and we'll take a look at what I mean by that. And they're going to be translating essentially the vCenter objects into Kubernetes objects. So if we're looking at the picture to the right here, and this is pulled directly from the VMware docs, we can see kind of how these components interact. So at the bottom there, we have vSphere storage, and we have an FCD virtual disk, which is a first-class disk. And that's going to be actually created through virtual volumes on top of our PowerStore environment. And we're going to see how that happens dynamically. So once we have this disk available to the vCenter environment, it has to find a way to attach it to our vSphere pod or the pods that are running in our subsequent guest clusters. So the CSI is going to be there to translate that into the objects required by our Kubernetes environment. And that's going to be in persistent volumes, which then translate into persistent volume claims, which then finally get attached to our actual vSphere pods. All of that is going to be facilitated by storage classes, which are going to be created through storage policies within vSphere. And again, there's a lot of components that are go into this, but be aware that a lot of this happens automatically. These aren't things that you have to manually install. These are things that are integrated into the system as a whole. I'm just trying to paint the picture of what is this and how is it actually working? And there's several components that go into that. And that's because there's several environments that we're trying to create a single paradigm, a single development paradigm where we have one platform for virtual machines, guest clusters, and pods with access to all of the normal tools that you have previously in your enterprise today. So how you have access to your existing storage. These are the different tools that go into that process. So why is this important, and why is specifically PowerStore kind of a solution that's tailor-made for this type of environment? So first of all, you get a single platform that is going to be for your current environment as well as your future deployments. So a big hurdle in the way of adopting new technologies is the convenience, or rather the splash that it makes to your existing deployments. So a lot of you work, years on end, developing processes, developing policies to how you deployed virtual machines. So it would take a lot to understand the benefits of Kubernetes to then feel the need to deploy an entirely new infrastructure to take advantage of that. Because a lot of times you've built in those advantages into your policies that you have today. Perhaps they're homegrown solutions, whatever they may be. But a lot of times it takes a little longer to adopt the cutting edge technology just because of the breadth of knowledge you have to earn, the time it takes to deploy it, and the additional infrastructure it usually requires as well. So the goal here is that if you're running an environment, a simple vSphere environment today, and you have a Dell PowerStore as your storage appliance today, you have your backup policies, you have your replication policies, maybe to another site, you have your snapshotting, you have your performance metrics built out in a specific way. You don't feel the need to deploy an entirely new infrastructure for your future workloads. You don't need to deploy all new bare metal for other Kubernetes deployments or anything like that. So what we're going to do is turn vSphere into Tanzu. So we have our vSphere platform supports Kubernetes. And then through those different components, that CSI, the VMware Cloud Native Storage, we're now going to turn our PowerStore into a cloud native volume manager. And what it's going to do is dynamically create volumes as first class disks. And it's going to attach those to our pods. So we can treat them exactly as we've been treating our existing applications without learning an entirely new paradigm of how to work with storage within Kubernetes. A second benefit of this, and this is a benefit really towards vSphere but Tanzu specifically and how it integrates with PowerStore, and that is self-service storage. So we'll see during the demo, I'm going to go over, from the perspective of a developer or from the perspective of an application owner, I'm going to create a persistent volume claim against a storage class that I've been allocated through the vSphere administrator. And that's going to dynamically provision the appropriate volumes for my workloads. So I don't have to request, separate workload volumes. I don't have to request disk space. I make the claim myself. And then if my claim is within the guardrails of the administrator, then I get automatically provisioned the storage required based on the class or based on the size, directly as I need for my application. So it creates a very simple and easy self-service model for not only self-servicing your application owner for deploying their own compute resources, but also their storage resources as well. And that kind of goes into that third point there, which is just operations and developer app owner cohesion. And this is part of that whole, easy DevOps model, allowing the vSphere administrators to become platform engineers or operations engineers solely without worrying about the applications, and handing a little more freedom over to the developers and application owners within, the guardrails that you set, so that they can handle a lot of the different nuance within their environment. Oftentimes, there's a ticketing process. A developer needs to have a virtual machine to test out something. So they go through a ticketing process. You have to provision a virtual machine, provision to the spec that they want, and then you hand them, an RDP session, say, here's your virtual machine, have at it. But you have to manage the storage for that virtual machine. You have to manage the network for that virtual machine, and you had to also deploy it yourself. It'd be, there's other solutions for that. Obviously, there's automation such as VRA and other things with blueprints and, everything that goes along with that. But oftentimes those solutions are quite robust, and they require additional overhead and additional management overhead that perhaps you don't have the time for. So what this allows you to do is create a platform, set guardrails, and then hand the keys over to your application owners so that they can be responsible for deploying their applications. And then all of the other underlying infrastructure, the compute resources, the storage resources, and the network resources are all going to be automated in a way that you don't necessarily have to interact with. Because this is all going to be occurring on a typical, vSphere environment, you also don't have to reskill. You don't have to learn an entirely new platform, whether that be Dell PowerStore or vSphere, if those are what you're adopting today. you don't have to learn an entirely new platform and a new paradigm for application development just to deploy or give your developers this platform to deploy onto. So it really allows you to retain the skill sets that you've kind of earned over the years, and how to troubleshoot, how to deploy a vSphere environment, and it kind of brings that into the next generation of microservices, containerized applications, all of that good. All those good buzzwords that we've been hearing so frequently about, the new way that we develop applications and deploy them. So with that, I'm going to go ahead and jump into the demo environment, and we'll take a look at what does all this actually look like, and how is it actually, ran in a live environment. Okay, so what I'm looking at here is a normal, typical vSphere environment. So what I have highlighted here is just a 2-node cluster, so it's quite small. I do have NSX deployed, a vCenter, and then I have the VSI OVA, and this is the storage integrator. So we're going to take a look at what this plugin does and how this actually provides us the benefit, and what are the additional things we can use this for and integrate into our PowerStore deployment. So first off, let's look at, I opened this up with the discussion of what is the architecture, the framework of vSphere with Tanzu. So I have my 2-node cluster here. I have this new paradigm here, this new object called the namespace, looks like a resource pool. And within this namespace, I have my supervisor control plane. So this is the Kubernetes control plane. Much like how you typically would virtualize your vCenter, that's your vCenter, your vSphere control plane. We now have a secondary Kubernetes control plane we can interact with. This is how we have the 2 different APIs that I had at the beginning. You have your vSphere operators interact with the vCenter API, your developers interact with the Kubernetes API. This is how this is actually facilitated, but they're both managing the same physical infrastructure. You see here, I'm running Kubernetes version 119. And we see I have the 3 master nodes, and my 3 worker nodes are going to be my actual ESXi hosts. That's just a lay of the land of the actual, the Kubernetes, how it's set up. And within that, I have my namespaces. So my namespaces are going to be the component that is the landing zone for my developers. So as a vSphere administrator, I will create a namespace, and then I will set parameters to who can do what, when, and why, and with what attributes for this namespace and how they can deploy on top of this environment. So we can see here, I set permissions. I can have this as a developer owner namespace. So I can determine this by users. And if you have your environment connected to perhaps an Active Directory environment or any other environment, you can use that within here to allocate group access, or maybe you have a team that needs access to this, so on and so forth. But similarly from there, I can attach storage policies, and this is what we're going to look at in just a second. But I can also set guardrails for how much storage they consume, how much memory they can consume. And right now I have no limits. This is just what I'm actually using. But you can set these guardrails for your environment. We look here, the Tanzu Kubernetes grid service. This is the deployment of our subsequent guest clusters I was referring to earlier. So we can see here that I do have a separate guest cluster. So I do have a secondary Kubernetes cluster here, and this is useful for perhaps testing new versions, deploying more complex applications. There's a myriad of reasons of why you would deploy a subsequent cluster if that's the architecture of your organization. But we can see that I can deploy a lot of different types of objects in this namespace. I can deploy a Kubernetes cluster. I can deploy a normal virtual machine using the VM service. I can also deploy vSphere pods, which are essentially just containers. If we see, I just have a single container in this pod. And we can do this all within a namespace in a self-service fashion that's going to be guardrailed by the parameters that we set here. So with that, let's talk a little bit more about the storage here. So we can see here I have storage policies. And if you look at VMware and we're deploying storage policies, that's something that's very useful to determine where items can be placed on what sort of resources the actual persistent data will be placed. And we can take a look at how I made that storage policy here. So I'll just go ahead and create a sample one here to show you the interaction with VSI. So this is the storage integrator that we'll see here. So what I would do is create this policy. We'll have a new button here when you have this VSI enabled, this Dell EMC PowerStore vVol storage. And now we can see another section up here come up. So now we can say, let's select what is the QoS priority for this traffic we want to make. So let's say this, make sure this one is low. So we can set this as low. We can name it appropriately. I didn't really name it appropriately, but to let our developers know when we assign the storage policy to them, they can see that and they can determine, okay, my application, this one is a high priority. So I'm going to look for a high priority, high speed type of thing. We can go on and see which data stores are actually applicable to this. So what vVol data stores do we have that are connected to our PowerStore? And we can go ahead and we can finish this. And I'll cancel this out. Once we would make that policy, we would then assign it to the namespace, and then it would be translated into a storage class that our developers and application owners can then consume directly. The idea of having this VSI and this direct integration into our vSphere environment is really helpful from the perspective of, how do we know, how is VMware aware of our storage environment? So this is just the plugin, as you can see, and we can see that we do have a bilateral connection between our PowerStore environment as well from our vCenter. And through that, we can develop virtual volumes. So when I'm talking about virtual volumes, let's take a look at the actual PowerStore itself and see what does this look like. If I just bounce back and forth here, go back over here to this namespace, we can see I have a couple pods, I have, a cluster, I have, all this stuff going on. But what does that look like from the perspective of our PowerStore environment? So if you look at our PowerStore environment, just a couple things, this is a normal storage environment. There's nothing, cloud native essentially about this that alters the way you would manage it. So this is facilitating not only for my future environment, my Kubernetes clusters, my vSphere pods, anything like that. It's also facilitating for my existing workload. So I can still see that, I can provide block storage, I can provide file storage. So I can have NFS, I can have iSCSI, I can have vVols, I can have fiber channel needing, and I still get all that benefit of efficiency that comes from having a storage array. So you can see here that I do have, quite a bit of efficiency going on from compression and deduplication. I have all the monitoring that you'd expect and performance you'd expect out of a normal storage array. But this one is connected to my vCenter environment. And because of that, I have assets. I have the ability to have visualization into the actual virtual machines that are consuming data on the storage array itself. So you see here, this is my subsequent or guest Kubernetes cluster. So it's TKC vVol 01, control plane and worker. If we look over here, let's say control plane and worker. And we can see that based on that, where are those actually connected? So we can see that there is a vVol container here. So these storage containers will act like a bucket that you can then provision dynamic policies or dynamic volumes on rather, as they're requested. So if I jump in here, I can see that I have 11 connected virtual volumes. So I can see the virtual machines that are connected. And so each one of the VMDKs for those virtual machines is now provisioned a dedicated first-class disk that is ability to be manipulated individually. So typically in an environment, you would deploy all of your virtual machines, all of your VMDKs, all of your pods, everything onto a single LUN or NFS data store. And they're all treated like lump files, right? They're all treated like they're one array, they're one LUN, whatever the case may be. But in this case, you can treat each disk individually, and all of these are provisioned at the time of meeting them. So you don't have to actually go in here and request storage to say, hey, I need a LUN for this VMDK. I need a LUN for this VMDK. I need an NFS data store for this VMDK. This all happens automatically through those integration tools that we talked about earlier, through the VSI, through the VASA, through the CNS, and the CSI controller. So you can see here, I have connections here. I have 11 volumes here. So now let's think about, I have this platform. I gave the keys over to my developer. What does it look like from their perspective? So from the developer, I'd typically be using kube control. So what I'm going to do is first log into my cluster. So what I'm doing here is I'm logging in as the developer. And I'm logging into that guest cluster that I deployed. That was the TKC vVol 01. I'll set that as my namespace. And now I'm a developer, and now I have access to this cluster, and I can deploy my applications as I see fit. So I can see my 2 nodes that I have access to. And within this, I can see actually how is my storage provisioned here. So if I look at, what pods do I have running? So what workloads do I have running? I have my 2 pods running. And in one of these pods, I actually have attached a volume to it. So if I look at my persistent volume claims. My persistent volume claim is how do I ask for storage? This is basically saying I created this claim. I'm asking for 5 gigs of capacity. I'm asking for read write once data access. And now what facilitates that? This is my claim, and it is bound to the storage class Tanzu vvol high. So if I go in here and I look at my storage classes, this is a storage class that's actually being provisioned by the CSI driver that we talked about earlier, that integration between vSphere and Kubernetes. This is what's being created because this is what the administrator had actually provisioned for me. So if you look at this Tanzu vvol high, this is actually the storage class that was provisioned to my developer from my administrator. So now he or she has access to this to deploy physical workloads to. And we can see here that I'm actually consuming, a 5 gig volume for that. Based on this provision or this persistent volume claim, a volume was dynamically created. And if I look back at my PowerStore here, we can see that these 2 objects here are actually the VMDKs or persistent volumes that were created with my pods. So you might be asking, okay, this is all great. This is how it all happened. So everything seems to be integrated in a way that I have, visibility from my vCenter into PowerStore. PowerStore knows about vCenter. My Kubernetes environment knows about PowerStore. It knows about vCenter. Everything is kind of this big triangle of things happening. But what if I deployed more workloads? So right now I have 11 connected volumes. Let's take a look at, I have some documents here to create new objects. So say I'm a developer, and I'm actually going to jump into a different context. This is actually jumping into the overall context. This is my main supervisor cluster. So if I get nodes to see what I'm actually deploying to, I can see I'm actually going to be deploying vSphere pods to my native ESXi hosts. So I have a few files here, and I'm just going to look at this nginx deployment file here. So if I look at this, it's a very simple deployment. This is going to be deploying my application. I'm going to call it nginx vvol01. These are just some labels for that. And then I'm going to actually create, I'm going to mount this volume to this path within my container. So I want persistent data for this container. I'm going to call this volume, it's going to be referencing nginx volume. So if you look here, I have this volume created, and this volume is going to be based off of the nginx persistent volume claim. So when this container starts running, it's going to look for a persistent volume claim and a subsequent persistent volume that I can then store this data. So when it looks for this claim, I also have this object up here, which is the persistent volume claim. So what this persistent volume claim is doing is, you can see the name is nginx claim, and it's referencing the storage class that I have access to. And again, that storage class is referencing a storage policy, which is mapped to my PowerStore virtual volume. And then I'm requesting 20 gigs for this. So once this object is created, it'll be a request. A volume will be created on my behalf on PowerStore. And then that volume would then be attached to my virtual machine, or my vSphere pod rather. So what I'll do is I'm just going to apply that object to my Kubernetes environment. So we'll take a look here, and it should create my nginx claim and my nginx deployment. So if I bounce over here and I take a look at, my namespace, we can see a new pod was created, my nginx vvol01. I can see that this now has a connection to my Tanzu block 1, which is that my virtual volume data store. And we can also see, if I go back over to my PowerStore, so this is my compute, right? So I automated deployment of my application. That was my compute component, but I also needed storage with it. So how did I automate the storage? If I look over here, and let's just refresh this. Now I have 13 virtual volumes. So now we see that dynamically, a brand new, based on this vSphere pod, a brand new VMDK was stored on a dedicated virtual volume that I can now treat just like any other virtual volume in my environment. If I have a replication to a disaster site, it can throw it right in that policy. If I have, nightly backups or whatever the case may be, snapshotting, anything you're doing with your existing vSphere environment, you can now incorporate your new applications or your new development paradigm into your existing policies and practices to ensure that all of the work that you put into creating the environment you have today doesn't get thrown away just because you're trying to adopt a new technology. The goal here is to adopt the new technology to provide you those benefits without detracting from the work that you've already put in to your existing infrastructure. You don't want to have to take, one step forward and 2 steps back. Just take 3 steps forward. I mean, it could be just use the platform you have today, enable it with the tools that are provided, and use those integrations to your advantage to ensure that you have the visibility, the capability to deploy this in a brownfield environment, and start developing applications in a different way. So with that, this is just a solution overview and just a little bit of what we just talked about. And the whole idea here is that we're utilizing PowerStore and its deep integration into vSphere to provide insight, a bilateral insight from our compute resources to our storage resources, and then how to integrate those into our modern application or our Kubernetes, in this case, Tanzu environment, so that everything works together as you'd expect under your existing paradigm that you have today. So with that, that's all I had today. Appreciate everybody for joining, and take any questions if there are any.
Hi, Billy. Yes, we do have one question. Does Tanzu require vVols to connect to external storage?
Yeah. So in this instance, I use vVols because that's an integration you can get with PowerStore and other storage providers, and it allows you to dynamically create those volumes as we saw. However, that's not necessary. You can still use any storage provider that can connect to vSphere. You can use with your Kubernetes environment as an endpoint, as long as it falls into a storage policy, which you can just tag any storage and put into a storage policy. It'll be presented to your Kubernetes clusters through that CSI, that container storage interface, interacting with the cloud native storage service within vSphere. So that same translation is still going to happen from like your persistent volume claim will still be translated into a volume created on the storage class. You just might not have the ability to deploy it as a independent volume that is dynamically created at the time of needing it. So you can absolutely use it without vVols, and they are a requirement, but they do add a dynamic benefit to individualize all of your disks for your environment.
Perfect. Thank you. That's all the questions we have for today. So thank you, Billy, so much for this webinar.
Awesome. Perfect. Thank you.
You bet. And for any questions, please reach out to one of the email aliases that you will see on the screen. If you could please move to that screen, please. Thank you. Sterling does record all sessions, so this will be available on our website later today at sterling.com on our proven performance page. Thank you again, and see you all next week. Have a great day.